Quotient rule. Okay, so this follows directly on from the product rule. In fact, later on this lesson we will use the product rule to prove the quotient rule. And so we use the product rule when we want the derivative of a function that we're multiplying. Here you can see we're dividing. So we need to recognise there's a function at the top and a function at the bottom. So we'll leap straight into it. With this one here, right, if you were to differentiate this using the procedures you currently know, we could split the denominator, okay? So we could go like this, is root x on 4x, take 5x on 4x, and then you can simplify using index laws and differentiate that way. That would be a very good way to do this one, because we don't need to go in and use the quotient rule and so forth. Okay? We'll have a look at this one over here in a moment, but over here you would not split the denominator because there's more than one term at the bottom. Okay, so that's a sort of general rule. If there's one term at the bottom, that's when we can start to split it. So, let's get into here. Obviously, the top function, u, is the square root of x, or x to the half, take 5x, and v is the bottom function, the denominator, which is 4x. And then just like the product rule, we go through, we find u dash and v dash. Alright, and then we just smash it together according to this formula. Now, in the past, people have made the error, it's always u dash v take. Alright, if you put that one first, then you've got it wrong. Okay, so we need to make sure it's u dash v, take away u v dash. So let's write that. F dash of x will be consistent with our terminology. If this is f of x, our derivative is f dash, u dash v, u dash v, take. U v dash, all on top of v squared. So 4x squared. And of course from there we could expand it and simplify it, collecting like terms and so forth. But we're not going to right now. In fact, that's where we're getting full marks. And I've said to you, we don't need to simplify unless it tells you to. And if you've completed the exercise for the product rule, you would have seen some of the later questions say, differentiate and show that the derivative is this. And we're going to go through one of them today. That's the only time you need to simplify, is when it says, differentiate and show that it simplifies to some other simple form of the equation. So we'll do a couple of them together. Okay, let's jump up here. We can see u pretty clearly, 3x take 2, and v is what's at the bottom. Now, u dash is pretty straightforward. V is a composite function. We've got some function to the power of n, which means we need to use the chain rule. So we're going to go n f of x, so n take 1, times f dash of x. Right, I think we're all pretty okay with the chain rule, so that's how we get v dash, and then we'll take it all together. Again, being consistent with our terminology, f of x, f dash of x, and we'll go u dash v, take. U v dash is nasty, that v dash, there's lots going on there. And all on top of v squared. So v is the square root of x to the 5, let's take 3x plus 2. So when we square a square root, we just decimate the square root, annihilate it, gone. So we can just express it like this. Any questions? Excellent. So that is the quotient rule. Let's leap straight into this exercise.